let's get going. So first, the three initiatives we are talking about, and these are like also the way how we advertise them, are related to cloud native architecture, to Kafka and Siebel UX. So some of the inspiration for this webinar we gathered from Oracle Siebel CRM Virtual Summit event back in September, like 3 months ago. And even though there were a lot of presentation and also many of you were presenting there, we kind of noticed that this cloud native announcement, which was done by Chandan, kind of didn't go noticed really well. And also if you kind of later read the blog post by Oracle, it was not mentioning there. And we just thought that it is like really cool stuff, which is Oracle is delivering to all the Siebel customers, and we need to pay attention to that. So it's going to be about cloud native. Then another thing which is developed together with this cloud native architecture, but also in a way it's going to be independently packaged and released, is Siebel event-driven frameworks, which initially will allow native connection to Kafka, which is popular data streaming platform. And then, of course, it is Idea Portriga who is hosting this webinar. We always talk about user experience and how to improve it with Siebel and keep innovating in this area. So definitely Siebel UX improvement is another initiative they're going to cover. And basically the way how I split them here is that, some of them are technical, like Kafka and cloud native. Some of them are more business focusing because we are actually going to deliver real values for the Siebel frontline users. And again, some of them could be tactical. So you don't have to change all Siebel UI, but improve just a few screens. So like tactical Siebel UX improvement, or it can be also strategical when you want to revamp entire Siebel estate from UI perspective. And then Kafka would also fit into tactical track and cloud native to strategic one. Even though yesterday, when we kind of had this little call with Oracle, George Jacob told that he see Kafka as a strategical improvement because data is coming into our world a lot, and they kind of did the Kafka thing so that we are able to cope with these modern requirements for data streaming and handling large volumes of data. But with that, let me start with the first initiative, which is cloud native. Some slide from September event. So this one was George Jacob in this strategy and roadmap explaining how Siebel infrastructure is changing and how they are starting to use more of the Dockers, which is actually not something new, or Kubernetes, which is also not something new. But then Chandan explained how they turned Siebel into cloud native application, ticking off all of the requirements of cloud native foundation. And then he kind of showed us this picture. And I think me, as some other Siebel guys, were looking at it and asking, okay, where is Siebel here? And what are the different icons are? And like, what we're supposed to do with that? Actually, the goal of today is that we will explain you some of these boxes and how Siebel is going to work in this new environment, and also maybe highlight the difference between the options available now, like running Siebel on Docker or on Kubernetes, and cloud native architectures that they are delivering. Also, in other sessions, they've done quite a lot of demos as well. Like 4 of them are really dedicated how Siebel plays in this Kubernetes cluster with all the supporting services around it. And another one was actually a demonstration of how it's possible to do now a native connection with Kafka so that we push some messages to Kafka topics and also read them from Kafka. And if you use this link, bit.ly Siebel Cloud Native, it will take you to Oracle Siebel CRM Virtual Summit page, to particular tab. And if you watch 2 presentations here, Oracle CRM Cloud Native Architecture and Technical Deep Dive, you will hear Chandan and his colleague explaining all the details from Oracle perspective, but also doing the demos. And they are kind of very impressive. To give a highlight here, first, some technical details. So maybe to some of us, cloud native means like, okay, it's not a buzzword like big data, API first, cloud here and there. Actually, if you investigate a bit there, so there is Cloud Native Computing Foundation, CNCF, and they have also the site CNCF.io, which is basically a foundation which is arranging different vendors and system integrators and projects, open source and not open source, so that they work together more or less seamlessly according to some standards in this cloud native environment. So effectively, we are talking here primarily about Kubernetes, which is running applications in pods, and the whole bunch of the supporting or backing services which provide observability, scaling, service mesh deployments. And today we're kind of going to explain what are these things in a bit more detail. So Alex Karch is going to do that. So then, and even though the name suggests it's cloud, in fact, yes, you can run it on Oracle Cloud Infrastructure or on Azure or Amazon Web Services or on Google Clouds, but you also can run it on-prem. So like if you have OpenShift platform there, it makes it possible to run it without leaving your data center effectively. So cloud means also private cloud or on-prem, if we kind of use more simple words, which is more familiar to many Siebel customers. And effectively what they are doing, so, Siebel itself is running just one of the services in this Kubernetes cluster, and we kind of configure how different Siebel services talk with each other, but also with surrounding services. A few more things on Siebel. The good thing is that in order to adopt cloud native architecture, you don't have to change any business logic, so it's all remain the same. Effectively, all the different object managers we had in past, they are still there, but the way how they communicate both with each other and with external services is being rewired in this cloud native architecture. But at the same time, if customers are not willing to go this way, so they can continue use the existing Siebel architecture as well. So basically, cloud native architecture is just additional deployment option for Siebel. If we kind of talk about Oracle safe harbor statements, then yes, they say that it's going to come 2021, but they cannot say where or when. And also what I found out yesterday is that you actually have to upgrade to the latest version in order to start using it. So, it is applicable only to the customers who are running on the latest versions. Maybe a bit more here. So if it kind of give you a bit more bigger picture, where is this cloud native architecture is coming from? And I think it is kind of important to stress here that Oracle is working on new software as a service offering targeted towards telecom clients called Digital Experience for Communication. And then they have some customers who want to try it, and some big names are there. So if you kind of go to Oracle site, you will see some interviews with Swisscom or with Vodafone. The whole idea for the digital experience communication that they built really nice UI using Redwood design system and their Jet components. Then there is a little integration layer that they use so that they provide all the APIs in TF forum compliant way. And then behind this integration layer, they have different systems performing certain parts of the digital experience. So Oracle is playing in one of them, which is related to sales experience. And then Oracle exposes some REST services in order to basically whole application to work. So effectively, what is changing, I think, for us as a Siebel customers are two things. So first, Oracle itself is starting to run Siebel in a massive scale. So they are investing into this offering. They have some first customers who are willing to explore it further and maybe start using it. And then Oracle itself has to start using Siebel internally, which is great, but also they have to do it in a way which is scalable, which provides high availability, which is not super expensive to run. And since they are kind of working in this agile mode, so they also need to have releases both frequently, but also releases shouldn't cost too much, and also they should be pretty safe. And basically, to make it happen, Siebel team have been working quite hard for the last year in order to come up with this cloud native architecture. So you can say that cloud native architecture is something that the Siebel community got thanks for this digital experience of communication offering, and that's, I think, great stuff. Also, it is going to be so that Oracle itself first is going to try it out, and not like, Siebel customers go to the latest version, install it, run into some issues, report it to Oracle, then Oracle fix it. Oracle is going to be sort of trailblazer in this cloud native approach, and having Oracle eating its own dog food is just fantastic to me. And I think also it will strengthen position of Siebel within Oracle. But with that, I will invite Alex to explain on the high level what is this Kubernetes cluster and how it works and what are the different backing services. So Alex, are you ready?
Of course, yeah.
Good.
Hello,
Okay.
everyone. My name is Alex, and I work with this cloud native initiative inside IDEA Puerto Rico. Juris already have mentioned a few words about Kubernetes cluster, but let me give a little bit more details for guys who have not been aware about it before. So in general, what Kubernetes cluster is, so it's open source container orchestration platform, and it automates manual processes involved in your usual application development and operating lifecycle, like deployment, managing infrastructure and network, operational procedures, scaling, and so on. As well, worth mentioning that Kubernetes cluster can be deployed to your on-premise environment, as well as on public, private, and hybrid clouds, and it makes it ideal for hosting these cloud-native applications. Also, I would like to precise on what cloud-native applications really are. So, in general, it's a collection of small and loosely coupled independent services, ideally built with this 12-factor app methodology in mind, and getting into what this 12-factor methodology enables for organizations. So in general, it's this thing that enables these fast development cycles, rapid and fearless deployments, small iterations, and altogether it results in reduced time to market and as well less development costs. So in Kubernetes, we are working with containers. These containers are wrapped in Kubernetes resource called pods, and network towards these pods is provisioned with the help of services inside Kubernetes. Also, Kubernetes provides different features like replica sets and horizontal pod autoscaling, and this helps you to run highly available applications with really minimum efforts and configurations involved, because in this case, Kubernetes will make sure that your desired number of replicas are always running inside your cluster, and it will help you to scale out or scale in your application based on current resource usage. So minimum manual operations, everything is taken by Kubernetes automatically with the smallest costs and efforts needed. Of course, there are some other use cases that usual organizations run into, like disaster recovery or infrastructure migrations, and Kubernetes and cloud native approach helps you and allows you to be able to restore all your infrastructure from zero just in minutes, or sometimes maybe even in seconds, with the help of so-called GitOps approach. It allows you to store all your clusters configurations and everything that should be deployed in your cluster in some Git repository with all its version control, and also sync all these configurations towards your cluster. So it will help you to reduce costs in case of disaster recovery, and also it allows you to really easily migrate from your on-premise environment into any cloud, or to switch cloud provider just in fractions of minutes or so without any complex migration work. Also, I think here is worth mentioning that Kubernetes cluster is immutable and resources there are immutable. That means that you can never change anything that is running inside Kubernetes. You should kill first old version and run the new one, or run the new version, check everything is okay, and then kill the old version. And thus it makes it really easy to operate your cluster, and you thus have always reproducible deployment process that you can reproduce on any other Kubernetes cluster. Of course, you should always take care of all your infrastructure, how it's behaving, either everything is okay, how it's performing, and you should be able to easily debug if something goes wrong. And here, cloud native architecture provides you different observability tools that could be installed inside your Kubernetes cluster and easily used there. And here in this scope, we have Elasticsearch, Kibana, and Fluentd for log managing. We have Prometheus and Grafana for monitoring all your applications and for collecting metrics and visualizing them in a good and usable way, and as well as Jaguar for application tracing and your request tracing to be able to check where your traffic is stopped, for example, or which of your application becomes a bottleneck in your performance. And last but not least is the so-called service mesh. It's the abstractions of how you might utilize your network inside Kubernetes, and allows you to easily configure all networking when you have, I don't know, hundreds or even thousands of containers inside your Kubernetes cluster. And here we will be talking mostly about Istio. Istio is a service mesh provider, and inside your cluster, it will help you with traffic management, it will help you with load balancing, with traffic security, both between your containers inside Kubernetes and as well as for all the incoming traffic, so-called ingress, or for all outgoing traffic, so-called egress. And as well, it provides another layer of observability of all your infrastructure, so you will be able to easily how your applications are communicating with each other with the help of Kiali dashboard on top of this Istio.
I think kind of the difference between what you were able to do with Siebel now and like running it in Dockers and Kubernetes is that Siebel is turning into one of this application developed using 12-factor app methodology, and then it communicates nicely with this all different backing services around it. So Oracle will be kind of shipping standard configuration for all these different supporting services around it. Also, they will have some basic dashboards prepared for us so that we are able to monitor Siebel performance and also see the logs in a kind of a not a better, maybe better way, but still different way, and which is I think more standard way. But also we can with Kibana build our own dashboards as well. So they kind of want to provide some kind of basic configuration for us, and then we will be able to further customize it to fit our needs. The way how we as a Siebel customers will gain benefits out of it is like, I think kind of I see three areas. So first is about this high availability, scalability. So, Alex explained that there are these core features in Kubernetes, like replica sets management, when whatever is falling, it's starting up again automatically. Also, we can set it up so that if we see that the Siebel service, particular some of the Siebel service starts performing not so great as we would like it to, then automatically horizontal pod auto-scaling process kicks in, and it automatically deploys additional pods so that they take all this extra load and even out the performance. And thanks to this immutable architecture, when we basically do not upgrade services, but instead of that, we deploy kind of new version of the service, route the traffic, see if this new service is running fine, then route whole traffic to this new version of the service. In that way, we can achieve this zero down deployments. Here also kind of Chandan mentioned that this zero downtime or like resilient architecture, it will work fine kind of for REST-based approach, but still, for example, if there is a pod failing on which currently users are working with from the Siebel UI, so of course they will need to relog on as well. But it's still, the whole process is going to be much seamless. So basically, we should have better performance, smaller service windows or outages of the application. And of course, with the scaling, we can rapidly build environments as we want them to, or take them down if, for example, UAT phase is over and we just want to release some of the resources. With operations, largely, it's about automation, this resilient architecture, so that a lot of management is done automatically and auto-scaling is done automatically. And we can believe that this monitoring dashboard will increase insight into what's going on within Siebel. And kind of another aspect to that is that on one hand, for Siebel administrator, this is like totally different set of applications and tools, that they would start to be using. But on the contrary side, if you take any DevOps engineer who is used to run and operate microservices-based application, modern applications, this set of tools is like very well familiar to that. And this is also why we kind of bring maybe Alex Kartyshev into this call, not Oleg Koleskin, because for Oleg, as a Siebel guy, these are like all new things. But since Alex was working in a similar setup before, these things look very familiar to him. So there is nothing new, and Siebel is going to be just one more service we need to run in this cluster. And the final point here about this agility and innovation. So, of course, one obstacle we have with Siebel deployments is that there is always risk that something will go wrong. And also we need to have like additional manpower, administrators, maybe super users, maybe some developers to support deployments. And that's why we cannot maybe run them as often as business needs to. Thanks to this zero downtime capability for deployments, low risk of failure and low cost, thanks to automation, it becomes much more affordable to run deployment cycles in a safe way, but also cost-effective way. We kind of move on really quick here. So as for the next step, so I kind of recommend you to watch this recording from Siebel CRM Summit. So once again, the link is bit.ly Siebel Cloud Native, and you will be going to this page. These two presentations are the ones that you are interested in. Next thing is that maybe you can ask around within your organization if you are already running Kubernetes, and there is a good chance that you are running. Then next week, Monday, we have another webinar which is dedicated just to this Kubernetes stuff. So Alex is going to run it if he will not go to paternity leave, so anything can happen. But the idea is that we will show you one of our applications, which we also migrating to this cloud native architecture approach. And then we will show you hands-on how all the different beasts that Alex mentioned play together and what do they do. Then next, you could start learning and mastering Kubernetes and maybe first taking on some non-business critical service. And in particular, it's going to be our transition point to Kafka. Like, if you start running Kafka, you can deploy it in the Kubernetes cluster and get some integrations going there, get some experience once again, get familiar, get confident that you can run it. And then as a next step, you consider adopting Siebel Cloud Native architecture when Oracle is going to release it. Okay, then we're going to jump to the next topic, and I think we'll have to increase the pace a little bit here. So Kafka, first, Kafka is one of the standard both open source tools, but also there is commercial version supported by Confluence platform for data streaming or for event-driven architecture support. And internally at Idea Portriga, we also have like a lot of discussion is like, what kind of beast is this Kafka? Because on one hand, you can look at Kafka in a very simple way, that is a message queue. So there are some services which are pushing the messages, some service providers, and then there are some consumers which are taking the messages from the queue. But of course, from the very beginning, the way how Kafka was built, that they have been focusing a lot on the latency, so that the message or the update from one system to another happens within milliseconds. Again, depends on your setup, but on the Kafka side, they can quote like 2 milliseconds as a level you can get to. And also it handles large volume of messages per day. So it is very well scaling, capable to process quite a bit of messages at the same time. But maybe what makes Kafka a bit different from that perspective also, and what is different from kind of modern message queue system or like RabbitMQ, is that the way Kafka is designed, so they do not mind storing all these messages if you want forever. So they look at all these changes or events which are going through the queue or through the topic as a event log, and at a certain moment they say that okay, maybe Kafka itself is a database you can do cool stuff with. So instead of just looking at the record status, which we have only latest, by looking at this event log in Kafka, you can see, how it was changing over time. And then based on that, you can start to do some cool stuff with this data. And this is like where we are going to event streaming capabilities, which Kafka provides. And this is also the way how it stands out from traditional message queues, how you can apply different logic on the data, which is going through the topics, and do some analysis, some calculations, some analytics, and based on the outcome, just push another message to another topic so that something happens in your ecosystem. Okay, with the Siebel, also it's expected in 2021. Also, you need to upgrade to the latest version. On one hand, this event-driven framework, which Siebel is going to release, it is not tied to cloud-native architecture itself, so it's going to be a separate piece of work, meaning that you can start using native integration with Kafka without becoming cloud-native or running on the Siebel cloud-native architecture. But also, Siebel itself in this new cloud native architecture is going to be using Kafka internally. So as I understand, they are going to replace Service Broker with Kafka. And basically, if you are running Siebel in this cloud native way, you will have Kafka in your cluster already. So meaning that you can start leveraging for another use cases as well. One point here is that we talk about native cloud Siebel Kafka integration. And what we mean here is that within Siebel, you can start working with Kafka topics. So basically, you can configure your runtime events, or within your script, you can start, either publishing messages to Kafka topics or subscribing to Kafka topics and getting the updates, the messages as soon as they arrive there. But also the last point here that you can use Kafka, of course, already now. We're using it for Konecranes. As an adapter, we use this change data capture technology, which is working on the database level. And also you can write some custom connectors, and Dmitry will explain a little bit more about this. As for the use cases, some of them are a really kind of simple one or on the surface. So for example, we can do audit of user activities within Siebel. It's like on one of our customers at Tele2, we've been implementing this functionality that due to EU regulations is GDPR, we needed to keep a log on what client data every user accessed at any given time. So, and it was done so that Siebel would push the messages to the Kafka, and then they would dump an Elasticsearch. And basically now, instead of making these custom connectors, we can use something which comes out of the box. Another scenario is that to enable these Google-like searches within the Siebel. So the idea is that through Kafka, with this really small delays, once Siebel data is changed, we push them into the Elasticsearch. And then on top of Elasticsearch, we have some API, and then we call it from Siebel UI. So basically, we do full text search on all the data we pushed into Elasticsearch. And by that, we find some records, some raw IDs, show them on the UI. And then, when user is clicking on a particular record, then they navigate it to sort of Siebel-backed UI, like traditional Siebel applets or something more fancy which is built. Another use case, which I think is like the first some customer we should adopt, and also this is actually how we use it at Konecranes, is that we want to replace read calls with data syncs. So the idea is, for example, at Konecranes, that there are mobile applications which are working on top of Siebel, reading Siebel data through REST services, which are getting better and better with every releases, Or maybe if these queries are like really small by, I don't know, like customer ID or service request ID, that they perform relatively well. But again, if they need to get large amount of data, like all customer assets, which could be like millions of records or hundreds of records at least, if they want to get all their customers, if we talk about sales scenario, then we kind of have some delay. So it's not like huge delays, but it is significant from the UX point of view. Users nowadays are not really patient, so they demand everything to be fast. So good performance is good experience or good UX. You can say so. And then instead of having these read APIs from Siebel, we decided to push the data into Cosmos DB. So we kind of also had to do some transformation in between, and kind of the details of this solution we can show in this next webinar next week on Kafka, how it works. But basically, in that way, we were able to dramatically reduce performance of these read requests. Also, we kind of offloaded Siebel from these heavy queries as well. So Siebel itself starting to feel better. But also, there is another scenario when instead of pushing Siebel data to another online channels or applications or mobile applications, in many cases within Siebel, we're using virtual business components when we rely on some third-party systems to get the data in the real time and show them in Siebel UI. On one hand, it's kind of handy way to get external data into the Siebel. But for example, with one customer lately, our team implemented 360-degree view of the customer, and they had few virtual business components, which is reading external data. And all of a sudden, users start to complain that this UI is loading like really slow, and they are not really happy with that. And but again, of course, if you understand what's going on the background, that you get whole bunch of Siebel data, but also then you in a sequence calling all the different third parties, getting results back. When you have everything back, only then you start serving to the UI. You understand, the problem you need to solve. And in this scenario, one solution could be that instead of reading this data from the third systems, we instead push them through Kafka into Siebel and then improve performance of Siebel queries. So they still remain, read only access, which we would need anyway. And of course, if we want to modify data, then we should use APIs in whatever, either somebody is updating Siebel data or Siebel updates third-party data. Then for commands, we go with REST APIs. For reads or for queries, data streaming or decoupling systems with the help of Kafka, maybe is the way to go. This final use case, which we're also going to show you in the Kafka webinar next Friday, is that leveraging this stream processing capabilities when we are able to look at sequence of events, identify maybe some opportunity or thread in those, and then act accordingly, basically produce another event which is consumed by some other application, and then it does something. For example, if we see that suddenly, there are a lot of card transactions going on from the different locations and it looks suspicious, this sort of behavior we can understand by doing the stream analytics. And then, for example, we can push the message to processing system saying that, blocks this card until we further investigate it. Or maybe it kind of from the opportunity point of view, then if we receive a call and if we kind of see particular things going on with this customer call, or in live manner, we can produce some opportunities and serve them on the flight to this particular customer. This all is enabled with Kafka stream processors. But maybe, Dmitry, if you can kind of explain a little bit on the high level how Kafka works, it would be, great.
Hello, I'm Dmitry, working with Joris and then everyday for Riga, also on Kafka capabilities, different Kafka scenarios. On a highly conceptual level, every user action, every change that was ever done to data, or every update in the database, that can be seen as a continuous, endless sequence of events. And as Joris already mentioned, events is one of the core concepts within Kafka, and Kafka builds on this idea. Basically, these events get stored into the topics, and they get stored and organized into topics. And these topics, well, we can say that this is a persistent storage of events that organize events in some way. So these events, on the one side, are produced by components, the producers. They on the left side. These producers may generate various kinds of events. It could be someone noticing your marketing post on social media. In this case, it would be some social media app producing the events. Then it could be someone of yours internal staff updating product information in an internal system. Or maybe a customer walked into your offline or maybe online shop and you want to capture this event. So basically everything that I mentioned can be an event, treated as event, and ultimately stored inside the topic. On the right side, consumers, that also might be different systems, they subscribe to these topics and may read events from topics starting from any point in time to make sure that, and this ensures that no event can be missed or lost, and different consumers can connect to the same topic and execute different internal operations depending on the nature of the consuming system that is processing events. So, for example, product information has been updated in the internal system that triggers the event and stored into topics. So with traditional single orchestration approach, you might want to create workflow with this event that basically takes this product information update, forwards this update to the marketing content management system, maybe notifies a responsible product manager to review this product information, to review this update. And also you might want to send this data to data warehouse as well for analysis purposes sometimes later. So doing all operations in the traditional orchestration would definitely cause a lot of headache to the maintenance team if one of the systems unexpectedly goes down, and it's usually tedious work to identify what has been left unprocessed, what have been processed, what have not been processed, and avoid double processing of some data. With event-based approach, this is mitigated because each of the system gets decoupled. They may take events from the topic only when they are available, when they're ready to process this message. This overall simplifies the whole integration flows and the whole orchestration flows as well. In case producers or consumers have no native capability to read and write events to Kafka, a number of components called connectors are designed to fill in this role. There are many existing connectors available as part of the Kafka Connect offering, Kafka Connect platform. Also, some of the connectors are offered by Confluent, either as part of the enterprise license, or some also are available as part of the community license for free. But if for any reasons these existing components do not fit environment, your needs, or maybe there is the target to source system implements some fancy interface, then custom connectors can be easily created. Last but not least, as Juris mentioned, stream processing techniques can be applied to events stored in topics to produce follow-up events. So these stream processors can apply traditional operations like filtering, transformation, enrichment, but more interesting scenarios and insights can be obtained from the stream of data when this processor can look at a set of events over a certain period of time, over a certain window. The typical examples for this window-based analysis are different fraud detection and anomaly detection scenarios.
Yeah, and basically, again, going back to this native Siebel Kafka connector, what we mean here is that Siebel as an enterprise application will be able directly talk to Kafka and also read data from Kafka, and it will not require any additional source connector or things connector if it's kind of going to consume messages. But before we have it, so it is possible to build those connectors as well. It's not like a big deal, and start using what Kafka already have in place. And I know that many customers are big users of Kafka. So in the virtual summit, we saw some presentation by Rabobank, and they are also one of the kind of leading or most advanced Kafka users. So because usually Kafka starts like the project initiative, but then it's get adopted by other projects as well or other applications, and then it becomes sort of central nervous system of the enterprise. And this is like where Rabobank is with their Kafka. So it would be kind of interesting to know how Rabobank and Siebel is using Kafka, but this is something maybe we need to ask Rene or someone else. All right, but let's move on. Yeah, another kind of interesting implication of Kafka, what we see is that coming from this microservice pattern, dump pipes, smart endpoints, Kafka kind of facilitates it. And again, I don't know how it's in your company, but usually with the projects we are working on, the integration scenario is such that we have like two systems, and then there is ESB in between with their different, they're like people-based processes or just message queue, and then they have all these different adapters for different systems. They have some transformation logic, some orchestration logic, and the challenge is that whenever we need to change the interface between these two systems, middleware team needs to get involved as well. And even though it's kind of nice from the architectural point of view, we still want to have this one guy in the middle who is taking care of all the messages, and that we don't need to replicate the same business logic functionality at each of the system. Still, they are a bit slowing down our velocity. So sometimes even it is so that when there is a way to make a shortcut and bypass this integration and just build point-to-point connection between two different systems, sometimes we do that, even though it's not nice from integration governance point of view at the company. With Kafka, it is kind of slightly changing in a way that having this connector built, either it's source connector or sink connector, it becomes responsibility of the producer system or consumer system. So basically, they need to do how to work with topics. And then basically, we have operation teams, which doesn't build anything because, again, in Kafka topics, there is no logic. It's, dump pipe. And all the logic goes to the responsibility of each team. But at the same time, we get the system with the high throughput, which scales very well, which provides asynchronous stuff and all these stream analytics capabilities, which we can just tap into that as well if we have some proper authority set up. So basically, in one way, we get some benefit from having the centralized solutions through which we talk, but it's not becoming a bottleneck from the development point of view. And this is just like one side effect of, kind of adopting Kafka versus traditional ESB. Not EBS, but ESB. It's kind of mistake here. Yeah, so it's kind of another way how to look at how we can arrange the integrations with us. And again, very quick, these are, again, the basic scenarios, which sometimes kind of obvious in a way. And during the next webinar, we will dive into this query performance optimization. So we talk about command to query responsibility segregation pattern, how we kind of did case with Konecranes, like separated mobile applications from Siebel. And then we will show some kind of demo to show you capabilities of this stream API. So basically, we will be looking at sequence of events going on, and if we detect kind of anomaly or too frequent update of the customer data, then we sort of raise flag in some of the system that this activity looks suspicious for some reason. Again, it's a bit artificial use case maybe, but just to show you the capabilities. And then you can look at your environment, apply your fantasy, your domain knowledge, and see what you can do with this technology. Well, next steps, watch recordings from Siebel CRM Summit. So Chandan explains more like how it's going to work and when they're going to adopt also not just Kafka, but advanced message queue protocol, which let's say RabbitMQ supports after Kafka. It's kind of spoiler for you. And also they kind of shown the demo how you will be able to work with Kafka through scripting, through the runtime events, and then special events they created to consume the data. And find out if your organization already have Kafka. And again, good chance is that you do have Kafka in your organization. Join the webinar to learn more. Try, learn, master Kafka with Siebel. And again, something which you might find relevant is replacing this read API with data streaming. And then maybe when you have these good use cases for advanced usage of Kafka with these stream APIs, then you can move to these scenarios as well. Okay, and finally, I will kind of speed up at this moment. Siebel UX, our favorite topic. Again, benefits of transformation really quick that we all see whenever customer we approach, that users and business stakeholders complains about too many clicks to complete the key task in the system. You see overwhelming number of fields on the UI, which is confusing the users. And then usually you get pretty long time to learn system and become very familiar, especially if it's a large Siebel configuration. Then through the UX stuff, so we look at ease of use, we look at look and feel, we use at learnability, we look at task completion times, change the UI for you, and then you have like immediate impact, primarily improved end user productivity, and thanks to improved usability and improved task completion time. We see that suddenly users start liking the system more, and of course, look and feel here plays important role. But also what is important is that there is less effort required for the onboarding and for the new employees to be fully productive. Again, learning the system and making less mistakes. And in the long term, we are talking about efficient business processes, increased employee engagement, which is sort of a new frontier now in the experience economy time. So customer experience is number one, but the employee experience is something where the companies will be focusing on in the future as well. And of course, its impact and user experience as well. Well, some clients go even further just to kind of measuring different metrics, how exactly the changes we do with usability improvement affect the business performance. We'll skip it here. The latest update on what we've been doing from a Puerto Rico perspective is that we have this, for us, it's ambitious goal that a team of 3 people could change entire Siebel UI within 6 to 9 months time. And it's not just technical work, it's also everything related to user research, to the UI design, to running usability test, to making sure that your application functionality certainly doesn't disappear when we roll out new UI. So all that work, but also configuring UI so that it's modern, using your design system or your design guidelines, and also easy to use and fast. So to do that, first, we have this methodology, which is, critical at this point because it's not just technology, it's methodology, very critical for overall success. So we took this famously used in UX domain design thinking methodology, adopted it for Siebel CRM UI redesign projects because making mobile app for the end customer and working on sophisticated UI for the call center agents, these are like two different things. But also at Siebel, we don't usually have large budgets to do the user research and UI design. So it should be like really pragmatic. And I think we kind of nailed it in a way. Then again, this summer, we announced Nexus Face. So during the summer, we ran 4 pilots with the customer. So installing Nexus Face in the Siebel environment, which is a challenge. I mean, getting access to Siebel environment for the customer, then redesigning one of the use case and doing the UI on Siebel data in customer dev environment with Nexus Face. So it seems working fine. We kind of prove that it's really fast. And with some customers, with 2 of them, we are continuing now with kind of agreement negotiations. And then during the summer and the fall, we also did this Nexus applications. So basically pre-configured set of Figma prototypes and Nexus Face build applications so that you can sort of speed up the development of new Siebel UI even further. So to recap, Nexus Face, key advantages over scripting with the jQuery or with React or Angular using Nexus Bridge or directly is that we see performance or development speed. So it significantly shortens development speed as you would expect with declarative UI capabilities, but also we have all this pre-built wiring with OpenUI infrastructure. So it kind of natively works with OpenUI, but the UI you build is a little different. Again, we have a pretty good asset of the UI components, which are now a bit like 54 that we have. Most of them are coming from the Google Material Design libraries implemented in Vue.js, but then for every project, we would style them according to particular corporate design guidelines. And then knowing Siebel teams, we know that in most of the cases, they are not super advanced web developers. And for them, even to do stuff, on the jQuery on the level like Alex Hansal is doing, it is kind of steep upskilling needed in a way. Not to mention, to become professional React developers. Some people are going this way, and which is great, but also for the most of the Siebel team, it is a challenge. And basically, again, thanks for this low-code nature of the tool, it's much easier for Siebel teams with their current skill set, with basic JavaScript and CSS knowledge to start using the tools and build this kind of awesome UIs. Okay, Nexus Apps, like really quick. So first we did like investigating of different navigation patterns in different applications like Salesforce, ServiceNow, HubSpot, CRM, some other ones. We looked at different customer roles, like, how salespeople are using it, how end customer facing people at call center and branch are using system, and also how the back office handling service request to cases are using system. And based on that, we've built 3 applications. So like sales people focused, customer focused, like call center or branch, and also back office application. Then we have, again, high fidelity UI in Figma, which is like part of our workflow is to develop the great UI. And also they are being built now in Nexus application so that when we start the project, we're not starting like from zero, like, adding components to the empty screen or empty page, but we already take some pre-made parts of the application and basically map it to particular Siebel views that we have at the customer and change the logic a bit, and of course fields to fit particular client requirements. With this blueprint approach, so we can manage both small Siebel UI improvements, so like technical one. So we start with this kickoff and inspire project when we look at Siebel solution, prioritize use cases, and build inspirational UI for one of the cases on some sample data without accessing kind of Siebel, which is kind of hard to do right away because of all the NDAs, because of all the VPNs and stuff. This is like first part. But then if customer decides to go on, we can work like use case by use case. First here in moving in 2 to 3 weeks cycles, we do all the user research with usability tests, with user journey maps, with pure score calculations. Then we pick the best patterns from the Nexus applications, and based on those, we kind of design the new UI, make it high fidelity with all the fields, and then validate it both from the usability point of view with users, but also with the business stakeholders so that we're not missing any functional requirements. And then basically, produce user stories in Jira, and this is like where development starts. And we see that within 1 to maximum 3-week time, depending how much Siebel changes you need to do, because again, you can live with the existing Siebel views, or you can choose the way that you refactor some of the functionality behind the hood to fit this new workflow. It can be like 2 to 3 weeks to design like new UI from scratch with the Nexus Face using Nexus applications. And again, if we talk about larger transformation, so we start with the same kickoff, but again, here we kind of, instead of prioritization, we define high-level plan, in which sequence we're gonna change the UI. and of course build something inspirational, to get emotions up. Then we would do 1 to 3 months long project, depending on how big Siebel is, where we would do all this in-depth user research for all the use cases, like all the processes, all the roles. Then we would design new UI for entire Siebel application in low fidelity way, meaning that we'll have all the screens defined, all the navigation defined on the blocks or section of the data defined in the system. And then we would move into iterative development using agile sprints, when we would do usability tests and high fidelity UI design first, and then basically doing the builds, and then releasing this new UI in this agile manner. Again, for next steps, you can read more like how we do this user research and UI design. Also, more insights on this role-specific Nexus application we have developed in this page. Again, bit.ly UX Siebel. On next Wednesday, we'll have webinar with all the demos. We will show you how to work with Nexus Face and how these Nexus applications are working now. So please join this event as well. And of course, we can book a session to discuss free 2-week initial project, Kickoff and Inspire. And then if we kind of get going, then sign NDA, and then basically plan and run this entire transformation or UI improvement project. And again, we work on one hand like as an end provider of the service, but in some cases we work also with existing Siebel teams. So we share the knowledge, we teach them how to use methodology, we teach them how to use Nexus Face, or we work with partner, like we kind of currently doing in Chile as well. So we kind of really open in collaboration options here. And again, with that, we're done for today. So we still have some time for question and answer. Sorry for running a bit late with the presentation, but this is the time to ask the questions. And if not, just join the webinars we are planning next week. You can first go to Idea Puerto Rico homepage, go to Siebel section, and this is the place where you can learn about the topics we were discussing. Here you will have webinar replay. And then please feel free to register for Cloud Native session next Monday at the same time, Kafka next Friday, and then Siebel UX and Nexus Face next Wednesday.